Okay. Can you see the slide?
Yes, doctor.
Okay. We begin with this one. 2013 and 14. Question 1 is about PD controller. So not in the scope of test 2, so we KIV. Okay. And then question 2 for this set is on the lag compensator, not in the scope as well. So KIV, we do it after concurrent with chapter 4. Okay. And then go to the next set, 2014 and 15. This one is in the scope, is chapter 3. Okay. So, Anis Farisha, can you read for me question 1?
Boleh, Doktor.
English.
Question 1. A given system, boleh dengar kan?
Okay.
Okay. A given system can be conveniently improved with the existing design tools available in literature. Given a randomly selected open loop system as following: GS equal to K over S, S plus 8, S plus 12. The open loop boat plot for the system when K is 1 is given in figure Q1b. Using the gain adjustment technique in the frequency domain, GS can be improved to yield better response. As a control engineer, using the information given, you are required to solve the following problems. A. Determine the value of K from the boat plot so that a phase margin of 60 degree is obtained. Find the gain margin at this instance. B. Provide the transfer function of the system with the K obtained. C. Calculate the steady state error when K is as obtained in part B. D. Compare the K obtained by calculation with the one obtained from the boat plot. C. After a certain duration, the original system is needed to operate at gain margin of 30 decibel. Do the necessary gain adjustment to find the corresponding phase margin at this instance.
Thank you. Okay, this is the problem for question 1, where you are given an open loop transfer function, GS, and GS is equal to K, the gain, S plus 8, S plus 12. So, by looking at the transfer function, this is a third order system, and system type 1. Okay. So you are required to assume K equal to 1, assume. Okay. And then apply gain adjustment. Okay. So that you will achieve phase margin 60 degrees. Okay. So you have to find the K. And then find the gain margin at this instance. Okay, that is the problem. Okay. We try to summarize the problem. So To achieve solution, to achieve phase margin 60 degrees, what you should do is you have to find the phase curve where the gain margin 60 degrees occurred. So in this case, x minus 180 degrees plus 60 degrees. So this is the phase margin that we targeted. Minus 180 degrees is the baseline of the phase curve, and x is unknown. So we are trying to find the x. So we simplify these equations. So you will get minus 120 degrees. Okay. So minus 120 degrees is from the here. If you look here, the phase curve, this is a gain curve, and this is a phase curve. Okay. So if you look here, the between one scale to another, this one is 45 degrees. Divide by how many segments there? Gabriel, how many segments there? 1, 2, 3, 4, 1, 2, 3, 5, right? So it's equal to 9 degrees each segment, correct? Gabriel, tidur tak datang Nurul Alia? Here, between 60 and 40 is 20 decibel. So divide by how many segments there? Nurul Alia? 5. So it's equal to 4 decibel. Nurul Alia pun tidur. Itu yang tak syok. Okay. So now we try to find the minus 1 to 0. Minus 1 to 0 actually, where is it? Minus 1 to 0. It is at 135. 135. 126. It's between here. I think it's about here. Okay. That is your minus 1 to 0. Okay. So I can write here minus 1 to 0. So 1 to 0. So you do with me, do you print this handout? If you print, much better, because you can do it together. Okay, what is the frequency over there? Ng Yong Ming. Datang. Chen, what is the frequency over there? 2.5, am I right?
3 radian per second.
2.5 lah, what? 1, 2, is between 2 and 3, so 2.5, Okay. 2.5 radian per second. So you can see that from phase curve, okay, both fluid, phase equal to minus 120 occurred at omega equal to 2.5 radian per second. Okay. So at 2.5 radian per second, gain curve is what? At 2.5 radian per second. Somebody please off your microphone. The echo 2.5, which is here. Okay. So what is the dB there? Chiu? What is the dB over there? Kalau saya panggil nama, you tak nyaut, you tak datang I assume you tak datang. Chiu? Tak datang. Shu Peki?
Hello.
Chiu? What is the dB over there?
Negative 48 dB. 48. Negative 48 dB.
Negative 48 decibel. Thank you. So it is minus 48 dB. Okay. So the amount of gain required so that phase margin of 60 degrees achieved is 20 log K 48 decibel. Okay. So K is equal to 10 48 divided by 20, which is equal to 266. Okay. Previously was 1. So you have to tune the gain adjustment, the gain knob, so that it reach at 266. Okay. So that is the what do you call that? Again. Okay, so you have to find the corresponding gain margin at that instance. Gain margin at that instance is so we have to find the what do you call that? The gain crossover, sorry, the phase crossover frequency. So the phase crossover frequency, so I delete this one first, okay? Okay, I delete this one first. Phase crossover frequency, where the phase curve cut minus 180 degrees at here, correct? Lim, Jing, Yi, correct? Phase crossover frequency?
Correct.
Tak dengar?
Hello.
Kuat sikit.
Okay.
I
think correct.
You think correct? Correct lah, memang correct pun. So omega phase crossover frequency is 10 radian per second, where the phase cross the minus 180 degree baseline. And then we use this frequency at the gain curve. So what is the gain reading over there? Lim Zheng Yi. What is the magnitude reading over there at 10 radian per second? Lim Zheng Yi. Tidak. Ada ke tak ada?
Ada.
Ya. Minus 68 decibel. Okay. Okay, minus 68 decibel. So gain margin at that instant is find the omega PM first. Okay. Gain margin occurred at 10 radian per second, which is equal to omega PM. Okay. When phase curve cut minus 180 degrees line. Okay. Gain curve value at 10 radian per second is minus 68 decibel. Okay. So we know already that we have to shift the gain curve to 48 decibel, shift up, kan? Because we want to fulfill the phase margin 60 degrees, kan? So that's why when the gain curve shift up plus 48 decibel, shift up, the corresponding gain margin is equal to 68 that Lim Jing Yi read just now, minus 48 that Chiu or Shupeki read just now. So it become 20 decibel. Okay. So you must understand the concept, because this graph is already shift up 48 decibel. If you see here, it looks like been shift up a little bit up. Okay. Macam tu. This one is K266. So the next question is, provide the transfer function of the system with the K obtained. Oh, that one is very easy. Okay. That one is after K obtained at 266. So therefore, okay, K is equal to 266. And the open loop transfer function is GS K S plus 8 S plus 12. Okay. So therefore, GS is equal to 266 S plus 8 S plus 12. Okay. So far, okay? Okay, guys? Mohidul, okay?
Better.
Okay, doctor. Yeah.
Okay, okay, bye. Samjhi bye.
Samjha.
Samjhi bye. Part C is the steady state error. Okay. Steady state error. Calculate the steady state error when K is obtained as in part B. Okay. Calculate. Okay. Not read from the graph. Calculate. Calculate meaning that you have to use what? You have to use what formula? Tanyalah. Tanzimin.
Yes, doctor.
Question C, you have to calculate the steady state error. So in order to do that, we have to use a formula. What is the name of the formula? Tak tahu. Ghalib, what is the name of the formula to calculate ESS? Sleeping. Allah.
No.
I thought you sleeping.
No.
What is the name of the formula? By using final value theorem. Repeat.
Final value theorem.
Final value theorem.
Mm-hmm.
Okay, since the system is type 1, Wahid, so therefore KV is involved, which is equal to limit S to 0 as KDS. So this is what we call final value theorem. Repeat, everybody. Please repeat, final value theorem. Final value theorem. Final value theorem, okay. So KV limit S to 0 as 266. Am I right? Hello, guys.
Yes.
S plus 8, S plus 12. So you simplified KV now become, because this one is already cut, so become 266, 8 multiplied by 12, which is equal to Lim. Who's that girl? Name Lim.
86.
86. Thank you very much. 86? Kau biar betul. KV.
96.
266 divided by 8 multiplied by 12.
2.77.
2.77. Thank you very much. So ESS is equal to 1 over KV, 1 over 2.77, which is equal to 0.36. Okay, so that is the steady state error by calculation. And then the next question is to compare the KV obtained by calculation with the one obtained from the boat plot. So now you have to use the boat plot to find the KV. Everybody, please look at the graph. I advise you to print this one, this boat plot. Okay, so the question no need. This one, you have to print. Otherwise, you don't understand. Okay, and difficult to understand. Boleh tak? So you have to find the shifted one. Guys, you have to find the shifted one. So you have to, this one is 20, shift up plus 48 decibel. So minus 20 plus 48 become minus 20 plus 48 because you have to shift this curve up to 48 decibel. 28, am I right? Hello? Hello guys, 28.
Yes, doctor.
Yes.
28, So this one is 20 dB divided by 5. 4 dB kan? So maknanya 28 dB kat sini. That is 28 positive. The next point is this one is minus 40. Shift up 48 decibel become 8 decibel. Am I right? Hello?
Yes, Prof.
Hello? Can you see what I read now? This is the second point. This is the first point. Okay? So you can see that the something like this. So every point of the gain curve have been shift up 48 decibel. Each of the point plus 48, plus 48. So you will get this one at K266. Okay, guys, K266. Okay. So if I use the hard copy, okay, the hard copy of the workload, so the line will be cut at 2.5. Okay. So you use your ruler. Okay. So this is minus 20 dB per decade line. Okay. The green line is minus 20 dB per decade line. And it cut at 2.5. Cut here. So that is your kV. kV. Okay. 2.5 using a ruler. So it's difficult to show in the iPad unless you have a hard copy of it. Okay. Can guys? Hello.
Can, Doctor.
From both plot, kV is found by using minus 20 dB per decade line, okay, on the shifted curve K266, okay. what I can see is something like this. Okay, this is the K266, guys. Okay, so this is the 0.01, if I'm not mistaken. 0.1, oh, 0.1, sorry. Zero point 0.1. This one is 1.0. Okay, so this one is just now is 48 decibel, 28 decibel. This one is 8 decibel. Okay. Okay. And then the KV is occurred here. Okay. At 2.5 radian per second, which is equal to KV. Okay. So what is your conclusion? Both approach using calculation which is 2 point berapa tadi?
2.77.
2.77 Yeah, thank you. 2.77 and observation 2.5 is approximate the same. Agree? Agree, guys? Hello, are you agree? Agree, eh?
Agree, Doctor.
Agree je lah. Jangan cakap banyak. And the final one is new target. New target gain margin is 30 decibel. Okay. At omega phase margin, which is 10 radian per second. Okay. When phase curve cut minus 180 degrees line. Okay. At 10 radian per second, gain curve is minus 68 decibel. Okay, minus 68 decibel. So we come back to here. Okay, so we delete. Okay, so this is your 10 minus 180, which is here. And it goes here, which is here, which is a minus 68 decibel. Okay. So to achieve gain margin 30 decibel, So shift up the gain curve in the amount of how many? Shupeki. How many? We have to shift the gain curve up. Shupeki. To achieve 30 decibel gain margin, so we have to shift up the gain curve in the amount of how many? Tak tahu. Yaitu 68 minus 30, which is equal to 38 decibel. Okay, 38 decibel. So therefore, 20 log K 38 decibel, K is equal to 10, 38 divided by 20, which is equal to 79.43. Okay, so this is the gain adjustment that we need. Needed to achieve gain margin 30 decibel. Okay. After shift up gain curve 38 decibel, okay, the gain curve will cut 0 dB line at omega GM 1 radian per second. Okay, so omega GM is very important, gain crossover frequency, because it indicates the phase margin values. Okay, so therefore phase curve at omega GM 1 radian per second is minus 100. Okay, roughly. So therefore, phase margin is equal to minus 100 minus 180, which is equal to plus 90 degrees. Okay. Sorry. 80 degrees. Okay. Phase margin. When gain margin 30 decibel. Okay. Any question? Any question, guys? Ada soalan?
Doctor.
Tak ada?
No, ada.
Ada
I
soalan?
want to ask the question A, how you get the K already?
Sorry, how you get
The K.
which K?
For question A.
Wah, that's too far. Kamu jauh sangat. Ni. Ni ke? 266. Hello?
Okay.
What's the problem? K266, yeah? Anti-lock 1048 divided by 20.
Okay, doctor. Thank you.
Okay. Oh, you masuk lambat Masuk lambat ni. Okay. We have a break for 10 minutes, can? Boleh tak? Hello? Can we break for 10 minutes?
Okay, Prof.
Sekejap rehat sekejap, 10 minit. Okay, we continue. Finish this one and then question number 2, guys. This one is a light compensator. So KIV. Okay. Because we are not entering chapter 4 yet. So turn to 2015 and 16. Okay. QR code already. You already have attendance? Scan your attendance. Hello? Okay. Mohidul, we can hear your mic. Yeah, I open my mic always. Mohidul, are you there?
Yes, yes, Professor.
Can't hear you.
No, it's like you were playing music, so like we could hear you. That's what I tried to like warn you about. Yeah.
It's okay. Lim Jingyi,
Yes, doctor.
louder. I can't hear you.
Uh-huh.
Speaker kuat sikit. Lim,
Yes.
can you read question number 1? Speaker high volume, please.
Okay. Using a graphical method, define the gain and phase margin. From the bulk plot of a system, how do we know that the system is either stable or unstable? Then
Continue.
a unity feedback system has an open loop transfer function of Gs equal to 100k times S plus 100 over S times S plus 5 times S plus 10 times S plus 500. By using a frequency response technique, the bulk plot of the open loop system with k equal to 0.01 is shown in figure Q1B2 and Q1B3.
Okay. Continue.
Okay. For the first one, obtain the gain margin and phase margin of the system and determine the stability of the system. Question number 2, find the value of gain needed for the system to give a phase margin of 48 degrees. Determine the new gain K and the gain margin at this instance. Number 3, by comparing the gain margin in 1 and 2, explain the effect to the stability of the system. Number 4, using the K obtained in 2, determine the steady state error of the system for a RAM input.
Thank you. All right. So using a graphical method is already in the notes, but maybe I can draw something. Okay. 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 Excuse me. So this is your omega PM. This is your omega GM. Okay. So the above one is gain versus the square. Off microphone, please.
Doctor, are you not sharing the screen?
I'm not sharing the screen. Sorry, yeah. Okay, sorry. Okay, clear?
Thank you, Doctor. Thank you, Doctor.
So this is your phase margin. And this is your gain margin. Okay. So what is the status of the stability? Anis, Farisha. Baru masuk.
Ya, Prof.
Baru masuk. What is the status of stability? Is it stable ke, marginal ke, unstable?
Marginal.
Marginal, astagfirullah. Cik Ayi.
Stable.
Stable?
Uh,
No.
Unstable.
Leo, what is the status of stability of my drawing?
Unstable.
Huh? Sorry?
Wait.
Wait, okay.
Oh, you're drawing your off.
The drawing on my screen now.
Oh, stable.
Huh? Stable.
Stable.
Salah, mah.
Ah,
Suraya?
okay.
Siapa Suraya? Suraya.
Ya, Doctor, saya Amira.
Amira?
Ah,
Oh, apa nama dia?
saya
Nyamuk.
Amira Suraya.
Amira Suraya. Amira. Oh, Amira. Okay, Amira. Silakan.
Stable.
Stable salah. Setia. Ayo, yo.
Unstable.
Huh?
Unstable.
Unstable, guys. Unstable. Stable. Okay, unstable. Because the gain margin and phase margin negative. Okay, so I give you another one. Macam mana nak ambil test ni? Jawab pun salah. This one. This one. Excuse me. Kita tanya Ryan. Ryan.
Ya dah tahu.
From the diagram I draw here, is it what is the stability status?
Marginal stable.
Marginal stable. Astaghfirullahalazim. Anik Aiman,
Yes, doctor.
kau dengar? Kuat sikit.
Yes, doctor.
Same answer, same question.
Stable.
Alah, Jing Yi, Lim Jing Yi.
Stable.
System stable. Gain margin, base margin, positive. Okay. One more thing, one more drawing. Excuse me. Aiza.
Marginally stable.
Aiza. Tak datang?
Marginally stable.
Marginally stable. Gain margin 0 dB. Phase margin 0 degree. Omega GM sama dengan omega. Okay. So I hope you understand. Okay. If you look at the unstable here, okay. GM is above 0 dB line. And phase margin is below minus 180 degrees line. Kan? But this one, okay, gain margin is below 0 dB line. And phase margin is above minus 180 degrees. But this one is not above, it's not below 0 dB, it's not above, it's not below minus 180 degrees, due to the fact that the crossover frequency for both gain and phase is the same. Okay? Clear? Hello? Hello, guys. Can? Okay, this one. Okay. Okay. Q1 already done. Okay. Q1. A done. B is the open loop transfer function. $100K S plus 100. S plus Y, S plus 10, S plus 500. And given K is equal to 0.01. Okay. Correct, Obtain the gain margin and phase margin of the system and determine the senang aja. This one very easy. Anis. Anis,
Ya, Prof.
what is the gain margin and phase margin? As in gain crossover frequency? Gain crossover frequency. Kat sini. Di cross 0 dB tu berapa? Nes. Jumpa tak? Dah jumpa? Dah, lambat dah. 0.04 radian, 0.004. Sorry. Okay. Phase crossover frequency. Amira? Phase crossover frequency. Ini. Amira Suraya.
8.
Hah?
8.
Apa? In English, in English. Ini
Oh,
ramai.
8,
Kau ni
8 radian per second.
ni bukan kelas Melayu. Omega Omega PM 7.5. Okay. Okay, catat kan? Phase 7.5. Kan? So, gain margin occurred at Omega PM. So, gain curve value at 7.5 radian per second is minus 72 dB. So therefore, gain margin is equal to 0 minus plus 72. Okay. Ni kan 7.5. Lebih kurang kat sini lah. Okay. So this is your 0 kat sini. 0 dB. So dia punya gain margin somewhere here. Tu And then phase margin occurred at omega GM 0.004 radian per second. At phase curve value minus 90 degrees. Okay. Ini tadi. Ni kan. Omega GM ni kan. 0.1234 here. So dia dekat 90 darjah, minus 90 darjah. Okay. So therefore phase margin equal to minus 90 minus 180 is equal to positive 90 degrees. So stable lah, right? Betul? Stable. Next. So gain adjustment so that phase margin is equal to 48 degrees. Okay. So to achieve phase margin 48 degrees, okay, so we have to find the x. So x is equal to minus 132 degrees. Okay. Phase curve at minus 132 degrees occurred at where? Nur Arif. Phase curve at minus 132 degrees occurred at where? Tak datang. Alia? Minus 132 occurred at where? Minus 132. At what frequency?
Minus 132.
Ini adalah minus 126. So minus 132 is in between. Tengah-tengah ni. Kan?
Yes, Doctor.
Kan? Dapat tak dekat skrin tu?
Yes, sir.
Dan di turun bawah. Situ. Berapa?
2.5
2.5 radian per
per
second.
second.
So, at 2.5 radian per second, gain curve is how many dB? 2.5. Gain, Alia, help me. 2.5. 2.5 kat sini. So, naik. Kat situ. How many dB?
Negative 58.
Negative 56. Okay. Negative 56. You baca betul-betul tu, dia punya scaling tu. Satu kotak 20 decibel divide by 5. If I think, divide by 5. Okay. Is at minus 56 decibel. Okay. So, shift up gain curve plus 56 decibel. Okay. So 20 log K1 because we already have K 0.01 at the original kan. So kita put K1 to avoid confuse. Plus 56. dB. So K1 is equal to 10, 6, 3, 1. Correct? Mohidul? Betul tak? Correct? Correct, eh? Malik, 631. Sah? Malik. Allah.
صحيح يا دكتور
Sah?
صحيح
Sahih. Okay, sahih, betul. Okay, so therefore, new gain is K multiplied by K1. K is 0.01 multiplied by 631. Kam haza. How much? 6.31. Okay, new gain. Okay. Determine the gain margin and the new gain K, khalas, and the gain margin at this instant. All right. Gain margin at this instance is 72 minus 56. Okay, which is equal to 16 decibel. At omega PM equal to 7 radian per second. The difference. Okay. So by comparing the gain margin in one, which is this one is 72, am I right? And 2 is 16 decibel. Okay. Compare. One and 2. This one 72 dB. This one is positive 16 dB. So compare, what is your observations? Amira, Suraya. Bisa comment. Comment.
System
Effect to the
stable.
stability. Both stable kan? Both stable. Both stable. But one 72 dB is much better stable due to big value. Okay, it's more bigger, 72 decibel, more stable compared to the 16 decibel. 16 decibel reduce, become 10, reduce, become 5, reduce, become 1 decibel, and when you reduce again, it becomes 0 dB. So when 0 dB, it is marginal stable. Okay. Then using the K obtained into determine the steady state error of the system for an input. Macam apa tu? 4. Ashurizan. Ashurizan. Tak datang. Afif. Afif.
Ya, Datuk.
Ha. Steady state error. System order berapa, Afif?
1.
Astaghfirullahaladzim.
Sistem order.
Kau ni, kau ni nak, budak ni aku debik juga. System order. Fourth order. Kan?
4.
Pagi-pagi dah salah jawapan. System type, berapa? Nak
One.
cakap sangat.
1.
Okay, nasib baik kau. So, kita tulislah GS tu. 6.31 multiply 100 S plus 100 divide by 100. S plus 5, S plus 10, S plus 500. Kan? So, kita pakai apa? Using Afif. Pakai apa, Afif? Using formula apa?
Final value theorem.
Final
Value theorem.
value theorem, iaitu limit
S
0 S GS.
KGS.
Okay. S to 0 S tadi tu 6.31 100 kan? So KV equal to 5 equal to 2.5 kan? So 1 over KV 1 over 0. This. Finish. Understand, everybody? Any question? Khalid, any question?
Alright, دكتور.
Alhamdulillah. Balik.
نعم.
أنت فهمت؟
فهمته.
فهمتم.
نعم.
نعم. Alhamdulillah. Najiha? Najiha? Tak datang. Najiha tak datang. Cantik. Fakihah?
Faham, doktor.
Ha?
Tak ada soalan.
Garang ni. Fakihah?
Ya, doktor.
Any question?
No.
Lim Jing Yi? Any question?
No.
Tiu? Tiu Rui Jeng?
Good.
Huh?
No question.
No question.
Good.
Okay lah. Huh? No question eh?
No.
Tan Jing Yu?
Yeah, doctor.
Any question?
No qua.
Darren? Any question?
Yeah, should be no.
Bino? Okay, so I think we stop now. We see you again online on Thursday. Okay, we continue our revision. Okay,
Thank you, Doctor.
Okay, bye-bye, everyone.
Thank you, Doctor.
Thank you, Prof.